Hello, math fans. Something I've wanted to do for a while is to give a quick review of logs. I encounter so many students that have made it all the way to calculus, they've made it to the University of Washington, and they just say that they don't understand logs at all, which is kind of surprising to me because everyone should care about logs, especially if you hate your job. And there are days I hate my job. I like working with students. But logs are the most important function because they answer this question, which is when can I retire? And so I'm going to answer that question in just a second. Anytime you want to know when will I have enough money for something, when will I pay off my student loans, all of those are solved with logs because they're exponential problems. And so it's really essential that you know this function. Now, a lot of times students say to me, well, that doesn't make any sense because I'm going to make so much money that my financial advisor will figure all this out. And I always find it funny when a student says that because I'm like, you're pretty confident. Maybe it'll work out, but it might be nice to know a little bit so you don't have to 100% trust someone else with all your money. And I'm no good with money. I wouldn't claim that I know how these things work, but I'm happy that I know a little bit about how to work with formulas, and I can't just have a financial advisor talk to me and just make up whatever they want. So I really love logs because they tell me when I can retire. So I'm going to be super practical here and just how do I push the right buttons to solve things? And it's really easy. Okay, so let's say I have, 5 times 10 to the x plus 7 equals 400. Just a few warm-up problems. The goal is to undo. So if no one's ever taught you this, solving is easy. You're trying to undo 3 things. You're trying to undo adding 7, undo multiplying by 5, and undo the 10. You just need to know which button does that. Now, long ago, you learned the button that gets rid of a 7. You subtract 7. Now, there's a certain order to these things. So if you can ever do addition or multiplication, you do that first. And that's where students screw up, is they push the buttons in the wrong order. But truthfully, there are only 3 buttons to push. This should not be a challenge. Everyone can do this. The first button we're going to push is -7. And if you're using a basic calculator, you can do it. You can even hit enter as you go. There we go. So it's 5. And this is something I encounter a lot in my classes that students can't do. So I just want to show you, I think they're lost in other things, but this is by far the most common situation when you use logs, is you're solving for an exponent. The next thing you do is you get rid of the 5. You definitely want to get rid of the 5 first. So the order of things is isolate the exponential. So how do you get rid of multiplication by 5? You divide by 5. So it's simple. Divide 5. Enter. So you could train anyone. You can train I have students that come to me, they're like in tears. I can't do logs. And I understand that there's frustration, but it's basically 3 button pushes. Okay? You don't have to be an expert. And so now you just need a button. Somewhere on this calculator, they put a button to get rid of a plus, which was a minus. They put a button to get rid of a times 5, which was a divide. And they put a button to get rid of this. Now, there's a difference. You do have to know a little bit. There's a difference between this, which I would call a power function, and this, which I'd call an exponential function. In power functions, you use roots, and you're used to that. Square, you use square roots. Cube, you use cube roots. Exponential functions use logarithms, and those are the 4 inverse pairs. Addition, subtraction, multiplication, division, powers and roots, exponentials and logs. That's it. Those are the buttons you push. It's that simple. So this one, the button is log base 10, which is what we call log. So you write x. Now, a lot of students learn this as doing the same thing to both sides, which is perfectly fine, but at some point you got to graduate past that. On this calculator, what I would hit is log, and then I'd hit second, answer. Ooh. Equals. There we go. A few button pushes, and I got my answer. And the best part about solving, students say, well, I always make a silly mistake. Because of that, I can't get high grades. It's not fair. And so I say, you can check. Math is one of the few courses where you can most of the time know you're right before you hand in your test. I really like that about this. I mean, you go back here, plug this into your calculator, And if you don't get 400, no, you're wrong. So there's a weird disconnect I have with students, and I want to figure that out, which is that was essentially three button pushes and three numbers, and it was checkable. Yet I have students almost in tears that they can't solve it. And I want to bridge that gap. Okay, let's look at another one, and then we'll talk about why this function is so important. You can find tons of practice on this, and this is just one of the little bits of algebra I intend to talk about. By far the most important base is E, because it comes up in calculus so much. It's our favorite base by far. Everything can be written in the base E. So because of that, if I'm just making up numbers, same thing, you isolate the exponential, which means you divide by 2. Some people like to divide both sides by 2, but by the time you get to calculus, you should graduate to just doing that in one step. The button that's the inverse of the E base is log. So you write 3x is the natural log of 7. And all of this you can do as you go. You could do 14 divided by 2, which I hope you don't do. I hate it when I see students doing that. And then you can do the log of the answer. You don't even have to put the parenthesis. It knows in this situation. So this is a number. Something about the fact that the name is log and we write it this way bothers people. I would argue that the word subtraction is pretty darn long too. You just have a lot more experience with it. That's that number, and then you divide by 3. So then we're going to do that answer divided by 3. Boom. And there's no reason anyone should ever miss this on a test, because they can go back and they can check it. It's going to be close within a decimal. We like to use the natural logarithm the most, especially if we're doing calculus, because it comes up the most. It also comes up the most in financial problems, and so it's by far our favorite base. Okay, so then the last, most challenging situation has to do with the fact that there's a couple log rules, but really one, which is this log rule. And it has to do with exponential rules, and I'm not going to talk about that here. I have plenty of sheets on my page, but it helps you solve anything. So like if you have 2 to the x equals 57, you do the natural log. It's this, I call this a 10-star fact when I do this in class, and I surround it by stars, and I say you absolutely have to know this. So we do take the natural log of both sides, but they don't cancel. You bring down the x. And again, I think just the visual scares people, but those are all numbers. Log of 57 is a number. It's a messy number. This is like 4.04305, etc. 1, 2, 6, 8. And log of 2 is just a number. So this is x times 0.693147, and so on. So how do you solve this? Well, you got to get rid of a multiplication. You just divide. Now, once you get good at this, you save yourself a step, and you just write 57. There's also a change of base formula, which says this is the same as log base 2 of 57. But knowing that, to me, isn't that helpful, because in practice, you just use the natural log for everything. So you're never going to encounter the log base 2. But those are the same. And so when I would type it in my calculator, here's what I would do. I would do natural log of 57. I probably would type this all in. My policy for myself is if I can't fit it in the screen, I do it in pieces. But here I can mostly fit it in the screen. There's my answer. That's it. And then you can check your work. You can plug it back in, 2 to that power. So 2 caret answer should be 57. Boom, baby. Isn't that nice? We can check everything. We can know we're right. This should be a course you love. I always found it in my history course when I would write a paper, they would say B+, whether I spent 5 hours on it or 2 minutes on it. Some students like that, but I didn't like that I could never be sure I was right. This is a course where you can be sure you are right. Okay, so we'll finish with a little discussion. This is from my business math course, and one thing we talk about there is financial problems, things where you earn interest. And I have there's kind of a few lectures in a row, compound interest. Students like to call this the PERT formula. This is PE to the RT. That's a continuous. Those are called lump sum problems, where you put a chunk of money in and it earns interest for a while. And then we have so-called annuity problems, and there's various versions of that where you make regular payments. A loan is an example of an annuity, except it's an annuity for the bank. You're paying it down. When you're saving for retirement, it's an annuity. When you're spending your retirement, it's an annuity. Any question about how long until I have enough money, which would be here, or here, or here, or here, or here, you will need a log to solve. So money questions, this is vital. For my students, I hand out, if my students want me to go further, I can talk about how I derive these formulas, but that's not what this video is about. I do an example of my student loans and what my monthly payment was. And then I do an example of saving for retirement. And I'm going to grab that example because it's the question, it answers the question of why we should care about logs more than any other function. So they tell us when we can stop doing our job that we hate. There are parts of my job I like, but I wouldn't mind retiring so I could not have 1,200 students a year. It's a lot of students that are mad at me all the time. Okay, so this is, oop, there's my face. Let's get rid of that ugly mug. Okay, here we go. So here was this retirement. You know, I basically have something like this where I work. They force me to put money in it each month, and it's invested in the stock market. And let's say I plan to retire in 35 years, and I'll have this much. And that looks like a lot, but then you can calculate how long that money's going to last. And you say, well, it's only going to last you, 10 years. And you say, that's all right. I plan to die soon after I retire. It's a very morbid discussion. But probably this is not enough. So for this person, they might go, okay, how much longer do I have to work past 65? And so they go, all right, I'm going to start trying to figure this out. I need to get to $1 million. So they say, I need to get to $1 million. And a financial advisor might not know how to solve this. So it gives you they might just use a calculator. It gives you some power if you can solve it and you can show them the formula. They're not going to take you for a fool. And this is a certain type of retirement fund, but the principles are the same. We need to get that N. That N is actually the number of months in this setup. It's monthly, right? I should look. Yeah, monthly. How do you solve that? And students are like, too hard. So many students are like, I can't do that on a test. It's the same principle. We need to isolate the exponential. We do have a bunch of things to get rid of, but it's just some button pushes. Let's get rid of them. So let's put in $1 million. So to me, I never can quite understand. Of course, I'm a math person. Some of the challenges students see here, because I'm going to divide by 500. Let's get rid of that. Now, could I do this faster? Probably. But let's just do it in chunks. So I have 1.005 to the n, 0.005. And what happens is students try to plug everything in at once, or they look online for some formula, which is, if you have to look up a formula for every single particular problem in your life and you can't rearrange it all, you're going to be very limited. Let's get rid of the 1.05. 1.005. Ah, that was fun. So you get 1990.04. When you're doing financial problems, it's good to keep lots of digits till the end. Now, if I was doing this, I have a lot of experience. I would do more than one operation, but I'm just showing you the steps. So I got rid of, I'm just cleaning things up. I'm taking a sad song and making it better. I got rid of that. Then I got rid of this. And now I'd like to get rid of this. Now it's being divided, so I'm going to multiply to get rid of it. So times 0.005. And the nice part about writing out your numbers as you go is if you go to check your work at the end and you realize it's incorrect, you can check your individual steps. So like if you're taking a test, it saves you a little bit of time. Okay, I'm still not done. Let's take that and add 1. That looks pretty darn good. So we have 10.9502487.6. It's 1.005 to the n. And now it's time to use our favorite function. We're going to take the log. You can use the common log or the natural log, but the common log by far, or the natural log is the one we use the most. And then you're going to use the 10-star fact and bring down the n. And this is usually when people gloss over and they say, I give up. I'm just going to hope I make a lot of money and have a financial advisor. Fortunately, that doesn't work for very many people. And now I have a number here and a number here. Sometimes this is where students drop the ball. All you have to do is divide and you are done. The number of months is going to be the log of this number. So it's going to be the log of that answer divided by the log of 1.005. So it's it's a pleasing little calculation. It's not something, if this is the hardest thing you encounter in your college math career, you're doing all right. So it's that many months. Let's divide that by 12. I'd like to know how many years. Oh no, 39 years. So he's going to have to work 4 more years to get to that total. Boo. So what do they do is it contributes more than $500 at some point. If you can do it earlier on, then you can retire sooner. I unfortunately have 3 kids, and one that's about to go to college and 2 more after that. So I doubt I'll be able to retire ever. But I can calculate when I would be able to retire if I could put money away. So I hope you find that interesting. If you want to learn more about financial questions like this, again, you don't have to be an expert. I'm no expert, but you can go to my Business Math or Math 111 materials, and you can see several real-life examples, how you calculate them. Really, you just need these couple formulas: lump sum problems and annuity problems. Problems where you make regular payments, and problems where you put a chunk of money in. And from that, you can reason out most things. And I've used these a lot to sort of, in my life, to anticipate, okay, if I pay a chunk of money off, how much sooner will my students' loans be paid off? I've done that many times. And I'd like you to be able to do the same. All right, hope you found that interesting.